look at the definition at the top of your page, okay, where it talks about cubic and exponential functions. Now, cubic functions have that form where it is ax cubed. That's what we call to the third power. To the third power is cubed. Plus bx squared plus cx plus d. Alright? Where a is not equal to 0. So this is our basic form for a cubic. Once again, we are doing very simple versions this year because we're just getting our feet wet introducing to these nonlinear functions. So look at all the examples that are on the page. What do you notice about all of them? Look at all the examples of the exercises down below. What do you see, Viraj? Look at all the exercises on the page that I gave you. Do they look like this? Okay. What do they have? Dolan?
Ax squared
Cubed. Okay, right. Just like when we were looking at quadratic and I told you basic form for a quadratic is ax squared plus bx plus c, but every one that we looked at didn't have that bx term, right? Same thing with cubic. Cubic can become very complicated, but we're going to look at the very basic forms of cubics, which means that we're going to look at ones that have an x cubed term. Now, to be a cubic, obviously, it has to have an x cubed term. If it doesn't have an x cubed term, then it's not cubic. That's kind of in the name. Okay? Huh? All right. So, hang on a sec. So, like I was saying, in order to be cubic, then it has to have an x cubed term in it. Okay? It can have an x squared term in it as well. It can have an x term in it as well, and it can have a constant. But every example we're going to look at is going to have definitely a cubic. But then after that, it may have a constant, it may not, but it's not going to have an x squared and it's not going to have an x. Now, the advantage to that is, once again, that means that our graph is going to be centered around the y-axis. So it's going to always be centered kind of through the middle of the graph, and you don't have to figure out where your middle point is. Okay? So that's going to make it a little bit easier this year. Again, don't assume that's always the way it's going to be. When you start adding in an x squared term and an x term, that's going to change how your graph looks a little bit. Okay? But for this year at least, we're going to be centered around our y-axis. All right, so here they give us an example. Here we're graphing 2x cubed minus 1. Y equals 2x cubed minus 1. We're going to do this the same way as we did the previous section, which is we're going to create a t-table. So there's. Now remember, when I make my t-tables, I don't put that in between column. I just plug in x and then I just do that in my head or on a scratch sheet of paper and do I. If you want to show this middle column, though, of course you can, okay? But I just plug in, so just like what we did in the previous, since we know it's going to be centered around y, I want to use 0 and I want to use values above 0 and values below 0. Now, if I use -1, then I have -1 cubed. Now this is important. What is -1 cubed? Huh?
-1.
To the third power. Not -1 times 3. -1 to the third power.
-1.
It's -1. Okay, when we square something, it always is going to come out to be positive. But when you do something to the third power, if I have -1 times -1 times -1, well, a negative times a negative is, and then that times another negative makes it negative. So if I take a negative number to the third power, then my answer is going to be negative, right? Whereas if I take a positive number to the third power, obviously a positive times a positive times a positive is positive, right?
Really?
Oh, y'all. Really? Y'all just told me a positive times a positive times a positive is negative. It's not Monday, guys. We should be a little bit more aware. I know. Yeah. All right. So, if I have a positive number cubed, it's going to be positive, but if I have a negative number cubed, it's going to be negative, which means it's not going to be like our quadratic. We're not going to have -1 and +1 have the same value, right? If I plugged in -1, we got -1 cubed, which is -1 times 2 gives us -2, and -2 minus 1 gives us -3. So my value for -1 is -3. Now, if I go in and plug in +1 instead, then I have 2 times +1 cubed minus 1. So 1 cubed is 1 times 2 is minus 1 is 1. So, like I said, we don't have the same value for -1 and +1. We have different values, okay? Then, for 0, 0 is always our easy value because anytime you have 0, any of this, even if we had x squared and x terms, they'd all go away, which means your y is going to equal whatever that constant is. So in this case, our constant is -1, so 0 is going to be -1, right? Now, for the next value, they used 1.2. The reason they used 1.2 instead of using 2, anyone have an idea why we might want to use 1.2 instead of using 2? Okay, it'll curve at 2 also, but here's the thing. If I plug in 2, well, let's look at it for a second. If I plug in 2, I get 2 times 2 cubed minus 1. Well, what's 2 cubed?
8.
8. And that times 2 is?
16.
Minus 1 is? So the reason they use a very small number is because when you square something, it gets bigger. But when you cube it, it gets a lot bigger, a lot faster. I mean, think about it this way. Let's look at some values of, all right, let's look at a table of squared. So I'm going to come back to this. So let's go on to the next. So let's say if I have 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, like that. All right, 2 squared is 4, 3 squared is 4 squared is 5 squared, 6 squared, 7 squared. All right, let's look at cubed values for the same numbers. 2 cubed, 3 cubed, 4 cubed, 5 cubed, 6 cubed. All right. Do we see why we don't want to use big numbers when we deal with cubics?
Yep.
Because if you cube something, 7 cubed, I don't know that one off the top of my head. 7 to the third power gives us 343. So, as we can see, they're going to get really big really fast when we start cubing things. And if you looked at that example, not only were we going to cube it, but once we got our number cubed, we were going to multiply it by 2. So whatever big number we get, then we're going to turn around and double it, which is going to make it even bigger. So in order to make your graph not ridiculously large or to have to count by, I mean, if you plugged in 5, well, you're at 125. you're going to have to label your x-axis by, or your y-axis by like 20s to make it fit. So in order to avoid that, we're going to pick very small values. Again, you can pick, just make sure you pick things on either side of 0, because our graph's going to be centered around 0, so we need to know what's going on the right-hand side and what's going on the left-hand side. Okay? So let's go back to this. All right, so once we have our points, then we're going to graph them. So here were the points that we had. We had -1, -3. So we go to the left 1 and down 3. We have +1, 1, so to the right 1 and up 1. And we have 0, -1. And then we have 1.2, so just a little to the right of 1, and 2.5, so up 2.5. So does everybody see this shape? All cubics are going to have this basic shape. Okay? If you think about it,
It's a parabola.
right, if I had, oops, not that one. If I had this line right here and I flipped it upside down, that would just be that right there, wouldn't it? I mean, essentially a cubic is just like a parabola, only one of the sides is going to be turned down and the other is going to be turned up. Because, guys, because of the negative number cubed being negative, but the positive number cubed being positive, that's going to make it go in different directions, whether you're using negative x values or positive x values. But the shape's still going to be the same, because we're still doing the same things to the numbers. Just one of them is going to be doing that in the positive direction, one's going to be doing the negative. So it'll still have the same basic shape. So all your cubics are going to look either like this or like that. They can either start down and go up as we go to the right, or they can start up and go down as we go to the right. But they're all going to cut through one point. Now, what's this point going to be? Always.
0.
Well, in this one, it's 0, -1. But what's it going to be always? The D. Thank you, Dolan. Okay? Whatever constant you're adding is your y-intercept, right? Because that's where if x is 0, all the terms go away except for your constant. So whenever x is 0, your y value is going to be d. So the center of your graph should always go through your y-intercept, which is that last value, that's the constant value that's being added. So let's look at some of the other exercises down at the bottom. Let's see. All right, so let's look at number 1. We're going to look at number 1 and number 2 together. All right, so I'm going to make a t-table. Again, what points do you absolutely definitely want to include?
0, -1, and 1.
I would definitely include -1, 0, and 1. Absolutely, without a doubt, you want to include those. Then you want something that is a little above 1. You can use 2, but you may have to adjust it depending on how big it is. In this case, 2 is going to work well for us. So if we use 2, now we have y equals -2 cubed plus 2. Well, -2 cubed is?
8. -8.
-8. Remember, a negative number cubed is going to be negative. So -8, and then that plus 2 is -6. So if x is negative 2, then our y value is going to be negative 6. Remember, if you're not really confident with your negatives, you can use a calculator to check it. Okay? Dolan?
So negative 2 is negative 6, and we make that down there negative 6, or?
No, remember, it's not a parabola. It's not going to look the same on both sides. Okay? It's going to have a different value, so you're going to have to plug in all of them. Now, if I plug in, since we already have 2 in there, if I just erase that negative and just do 2 squared, what is, or 2 cubed, I mean, what is 2 cubed? 8. And 8 plus 2 is 10. So, negative 2 is negative 6, but positive 2 is positive 10. Okay? Negative 1, if I plug that in, then I get negative 1 cubed, which is negative 1. Remember, negative number cubed is negative. So negative 1 plus 2 is positive 1. If I do positive 1 cubed, that's 1, which plus 2 gives us 3. And of course, 0 is the easiest because it just makes this term go away, so I'm left with 2. Now, notice on our graph, it is labeled by 2's on both the x and the y. So don't make sure, if they label the graph for you, you don't have a choice. You have to use the way that they label it. If the one's blank, then you can pick. But if it's labeled for you, you have to graph it based on what they've labeled it. So I'm going by 2's. So my first point, negative 2, negative 6 means I'm going to go to the left 2 units, but that's really just one mark over. And I'm going to go down 6, but that's really just down 3 since it's by 2's, right? So here's negative 2, 6. So I'm going to put that point on my graph. Then I have negative 1, 1. So negative 1 means I go to the left a half a unit, and 1 means I go up a half a unit. So this point should be right here. 0, 2 means I go left to right, none, and up to 2, which is just 1 unit up, right? 1, 3 means I go to the right half a unit and up 1.5 units. And 2, 10 means I go to the right 1, because that's 2, and up 5, because that's 10, right? All right. Now, once again, this is important. We're not drawing straight lines to connect these things, okay? And one thing that you'll be tempted to do is draw like a straight line through that. But that's not the way it is. Remember, this is like a parabola turned upside down, so it should curve. From here, it should be kind of flat starting out, and it should curve up. And on the other side, it should be kind of flat from there, and then, oops, curve downwards. So your graph should have, it should be flat kind of in the middle, and then gradually curve and get steeper and steeper through that point. And so all of your all of your cubics should look like that. Okay, so don't make it a straight, because these will line up in a straight line. These 3 points always will, because one's going to be exactly the same distance above as the other is below. They will make a straight line, but that's not what your graph looks like, because if you found the values in between, they're not going to be on a straight line. So make sure you curve down to it and then curve down that way, and that's what your graph is going to look like. All right, let's look at the next one. Now this one is essentially the same thing with one big exception. What is that? It's a negative x. So I'm going to use my same values, negative 2, negative 1, 0, 1, and 2. But here's what we need to remember. This is negative whatever x is cubed. So if I have negative 2 cubed, plus 2. I need to first do negative 2 cubed and then negate it. So whatever negative 2 cubed is, which in this case negative 2 cubed is negative 8, right? So the negative of that is positive 8, okay? That negative out front is going to change the sign of whatever you get when you cube that number. So in this case, negative 2 cubed is negative 8. The negative of that makes it positive 8. And 8 plus 2 is 10. Now, if we do positive 2 cubed, for the bottom one, if we're doing positive 2 cubed is positive 8, right? But then I have to negate that, so that makes it negative 8 plus 2 is negative 6. Now, anyone want to guess what the value for negative 1 would be? 3. And the value for positive 1 is 1. How do you know that? Right, okay. Here, when I did negative 2 cubed, I had negative 8. Here, when I did positive 2 cubed, I got negative 8, okay, because it was the opposite sign. So the value for negative 2 was negative 6. The value for positive 2 here is negative 6. The value for positive 2 here is 10. The value for negative 2 here is 10. So it's just going to be switched because all we're doing is switching the sign. Okay? So negative 1 is going to be 3. Positive 1 is going to be 1. And 0 still will be 2. Okay? And now you don't have to know to do that from the graph, but I wanted you to see that relationship. Okay? It's basically going to be the same graph with one exception. This one's going to start in the positive y values and then go to the negative values, right? So we have negative 2, 10. So that's up here. And then we have negative 1, 3. So that's half a unit over and 1.5 units up. We have 0, 2 again. We have positive 1, 1, so to the right half and up a half. And then we have positive 2, negative 6, so to the right 1 and down 3. All right. And then once again, that makes a straight line, but we're not going to connect it with a straight line. We're going to curve because it should be fairly flat going through that middle point. Sorry, I have a hard time drawing this with my finger. All right, so it's going to look something very roughly like that. So notice, now remember we talked about with quadratics that before you even start to graph it, there were two things that you could pick out really quickly, right? You could pick out where it's going to cross through the y, which is going to be your center, your vertex, right? And we could pick out whether it's going to open upwards or downwards. Well, you can do the same thing here with cubics. We can still pick out where it's going to cross through the y very easily. And we can pick whether it is going to start at the bottom and go up, or whether it's going to start at the top and go down. Okay, that again depends on whether your x cubed value is a negative coefficient or a positive coefficient. So let's look just really quickly. We're going to make notes on the remaining ones on this worksheet. So let me do that real quick. Hang on. All right, so looking at number 4. Number 4 is going to cross through where? 0, right? Because we're adding nothing. There's no d value, right? So it's going to cross right through the middle of the graph. And then we can look at the coefficient. The coefficient of our x cubed value is positive 2, right? So it's going to look like our positive ones, which means it's going to start at the bottom, go through, and go up. Now, this is very rough graph. Okay, you need to actually create a t-table, but this is just, again, it's just like the quadratic ones where I said, okay, we know it's opening downwards, we know it crosses through this point. Does that tell you exactly what the graph looks like? No, it could be a really wide quadratic, right, or it could be a really narrow one. So you have to actually use your t-table to find exact points. But this gives you enough to kind of check whether your answer looks right. So if you're accidentally forgetting to negate your values when it's negative and you graph it wrong, it's an easy way to check it. So this one's should look like this. Now number 5 is going to cross through at 2. And the exponent, or the coefficient to our x cubed is negative. So that means this one's going to start up top, cross through at 2, and then go down. Again, very rough graph. This may very well be narrower, it could be wider, but in general it's going to have that shape and cross through at that point. So you'll still want to use your t-tables to plot it exactly, but this is just a way to double check that, okay, does it have basically the right shape? Because if it doesn't have the basic right shape, and unless I'm wrong, and I'm pretty sure I remember correctly, I think we put a lot of multiple choice questions on this test last year, and a lot of them, if you just knew the basic shape that the graph should take and where it's going to cross through y, you could eliminate all 3 of the wrong options and have only the right one left. Okay, so, I'm sure we'll use the same test as last year. So yeah, if you know the basic rules and you know, hey, this is where it crosses through y, and this is what shape it's going to take. It's going to either start at the top and go down, or start at the bottom and go up. Then you're going to be able to at least narrow it down to like 2 choices instead of 4. You know, so. So, any questions about how to do the cubics? All right, so your homework tonight is 6 questions from your workbook. Okay, so you'll need to do those 6 questions. Remember, don't do -2 and then assume +2 is the same. It's not. Okay, you'll have to actually plug in and work out all of them.
Nicole?
Yes.